So still on yield line analysis, we'll be looking at yield line analysis of a slab. That's the plastic analysis of a slab. All right. Now, before we go ahead to carry out this analysis, these are a few things we should note. So whenever we see this condition at any portion of our slab, it means that that portion of the slab is simply supported. And whenever we have this line representation, it means that point is fixed or is a continuous point. Now, before we go ahead to analyze this slab, which we can see that this point and this point are simply supported, let's take note of this expression. So we have our internal work done, okay? Okay, we have internal work done. To be equal to our length, okay, times moment times slope. So our internal work done for a slab is giving us the length of the segment we are considering times the moment times the slope. Our external work done is equal to our load, okay? So let me call that W, our load, times area of the segment times the deflection of the center of gravity. So whenever we want to obtain our external work done, we simply multiply our load by the area, the load acting upon the slab, by the area of the segment being considered, by the deflection of the center of gravity. Now, for this analysis, okay, deflection is considered a unit deflection. Hence, our deflection, okay, delta, is always equal to 1. So at any point you are considering, our delta is equal to 1. And also, our rotation is equal to our delta over the perpendicular height. So, okay, the height of the segment we are considering, all right? So our slope is giving us our delta over the height of the segment we are considering. Knowing that our delta is 1, this is always equal to 1 over what? The height of the segment being considered. Now let's go ahead and analyze this. So the problem says, determine for the slab shown the required moment parameter M if the design ultimate load is 18 kilonewton per meter square. Okay, so we are asked to determine the moment given this load. So what's the first thing we do? So whenever we want to analyze a slab using the plastic analysis, the slab is divided into segments which has already been done. So let's call this segment A, okay, let's call this B, let's call this C, and let's call this D, of which we know that our segment A and our segment B are equal. My drawing is not to scale. And our segment C and segment D are also what? Equal. Okay, where this is what? 45 degrees. Okay, this is also 45 degrees. Now the first thing we'll do is to sum our external work done, internal work done or external work done. So let's start with internal work done. Okay, so our internal work done, So we are basically going to get our internal work done at this segment, our internal work done at this segment, this trapezoidal segment, and our internal work done at this segment, and our internal work done at what? This segment. Now here is something we should see. Since this segment is equal to this segment, if we get the internal work done here multiplied by 2, we have gotten the internal work done at these two segments. Also, if we get the internal work done at this segment, okay, it is also the same value as this, so we multiply by what? 2. So our task now will be to get the internal work done at this segment A and segment what? C. So we'll consider, let's call this panel, so let's just call it panel. So let's say panel A, so let's just call that panel A, which is this segment. What is internal work done? It is simply what? Length times the moment times theta. So since we are looking for the moment, we are not giving a moment value. So this part, considering this segment, which is the base of this triangle, is our length. And this length is what? 5 meters. Hence, our internal work done is equal to what? 5 times, what's the moment we are not giving? M times what? Theta A. I will remember that our theta is always equal to what? 1 all over what? The perpendicular height. If this is the base, which is the length we are considering, the perpendicular height is what? This. And we don't know that yet, so we consider it to be what? X. So this is going to be equal to what? 5 times M times 1 over X. Hence this is equal to what? 5M over X. We know that panel A is equal to what? Panel B. So the internal work done at panel A is equal to the internal work done at panel B, and that is equal to what? 5M over X. Alright. So we have gotten for panel A. The next panel we want to consider is what? Panel B. Panel C. So we have for panel A and B, because they are the same segment, so they are the same value. So for panel B, panel C rather, okay. Now let me bring out this section, okay. So we have this. Right? We have this distance to be what? X. Okay, we have this distance to be X. Let's extend this a little bit. Okay. So we have this distance from this point to this point also to be X. Now, if from this point to this point is 10, and here is X, here is X, this distance will simply be what? 10 minus what? 2X. Removing the 2X. So we have this to be what? 10 minus 2X. Now, we want to get our internal work done. If we look at this trapezoidal segment, we have what? A triangle at this point. We have a triangle at this point. And then we have what? A rectangle at this point. What will be our task? To get the internal work done on this segment, we simply what? Get the internal work done on this triangular segment, multiply it by 2, okay? And then we get the internal work done at the rectangular segment. So let's call the rectangular segment C1. Let's call this C2. And let's call this C3. Okay, so for C1, okay, so for C1, remember we are trying to get what? The internal work done for what? Panel C, which will simply be what? The internal work done here plus the internal work done here plus the internal work done at this segment. Alright, so for C1, Remember, our internal work done is simply what? Our length. What is the length? The length is simply what? 10 minus 2x. So for C1, internal work done is equal to what? 10 minus 2x, which is the length, multiplied by the moment, which we are not given, multiplied by m, multiplied by theta. Okay? So at this point, what's the perpendicular distance? It is simply what? This distance. And that is what? We remember that our theta at every segment is simply what? 1, which is our deflection all over what? Perpendicular height or distance. So this is the length. This is what? Perpendicular distance, which is what? 2.5 meters, half of 5 meters. Alright? So multiply by theta, and theta is what? 1 all over 2.5. Okay? So this is equal to 10 minus 2x m all over what? 2.5. And this is equal to, so 10 times m all over 2.5 is 10m all over what? 2.5. Alright. 2x times m all over 2.5 is what? Minus 2mx all over 2.5. Okay? So 10 divided by 2.5 is what? It's 4m minus 2 divided by 2.5 . 0.8 what? mx. This is what? The internal work done for this section. Alright? So let's get the internal work done for this section. Noting that in this section now, this is our what? Our length. Okay? So for C2, alright, we have our internal work done to be equal to, our internal work done is equal to what? Length. Our length is what? X times what? Moment, m, which is not given, is what we are looking for, times our theta. Remember, theta is always what? 1 over perpendicular distance, and perpendicular distance is what? 2.5. So this is the segment we are considering. We are considering this segment. If this is the length, this is the perpendicular distance, and this is what? Since this is failing by 45 degrees, this is half, it's at the half mark, and this is 2.5. So that's what we are considering. So we have that to be times our theta, and our theta is what? 1 all over 2.5. Okay, so at this point, we carry out our multiplication. So we have internal work done to be equal to what? mx all over what? 2.5. So our internal work done at C, okay, which is what? This segment, alright, is equal to what? The internal work done for this rectangular segment, which is what? This 4 what? M minus 0.8 mx plus the internal work done on this point and this point. Since we have gotten 1, we multiply by what? 2. That's plus 2 into what? mx all over 2.5. So we have this to be equal to, okay, so 4m minus 0.8 mx, okay, So if we take this into this, it will be 2 all over 2.5 times mx, and 2 all over 2.5 is what? 0.8. So we have this to be, this is equal to 4m minus 0.8 mx plus what? 0.8 mx. And obviously, this takes out this. So our internal work done for this segment is equal to what? 4m. What's the next thing we have to do? We have to determine what? The internal work done at what? D. Alright? But we know that the internal work done at C is equal to the internal work done at D, because the segment dimensions are what? The same. We have the same segment. Hence, summation of internal work done is simply equal to the internal work done at A plus B plus C plus what? D. And that is equal to, what's the internal work done at A? What's the internal work done at A? 5m over what? Over x. The internal work done at B is the same, plus 5m over x, plus the internal work done at C is what? 4m, plus the internal work done at D, 4m, because they are the same what? Segment. So we have this to be equal to, so since they have the same denominator, we can add them, alright? So 5m plus 5m is what? 10m all over x. If the denominators were different, we would have taken LCM before adding them. Plus 4m plus 4m is equal to what? 8m. Alright. So at this point, we can add them, right? So we simply take an LCM. So LCM will be what? X. Okay? So at this point, so x divided by this is what? 1. 1 times 10 gives us what? 10m. 1 times 10m, 10m, plus, this is what? 1. X divided by 1 is what? X. X times 8m is what? 8m x. Alright. So at this point, we can factor out our m, right? So we have this to be equal to what? M into what? 10 plus 8x all over what? X. This is the expression for our what? Internal work done. Alright? So our next step should be to do what? Carry out summation of external work done. So our external work done. So also we'll be starting at this segment. So let me call that segment panel A. Alright? Panel A. So at panel A, what is our external work done? External work done is simply equal to what? Our load times the area of the segment times what? Deflection of the center of gravity. So our deflection is 1. Our center of gravity for a triangular section is 1/3. Okay? So our deflection of center of gravity, whenever we are considering a triangular portion, is always 1/3. And our deflection of center of gravity also, when we are considering a rectangular section, is 1/2. Okay? So let's get this. So for panel A, what's the given load? We are given what? So for panel A, external work done is equal to what? The load, which is what? 18 times, what is the area of this segment? It is a triangle, hence is what? Half base times height. Okay? So this is what? Our area is what? Half So this is the area. Half, the base is what? 5 meters times the height is what? X. This is our base. This is our what? Height. And our height is what? X. Times our center of gravity. Remember I said for a triangular section our center of gravity is what? 1/3. Okay. So we have this to be equal to 18 times 1/2 times 5 times 1/3 times. Okay, so we have this to be 15x. All right. So that is it for panel A. So also for panel B, since it is the same segment, panel B is also what? 15x. So let's go back to panel C, which is segment C. So our external work done is simply equal to what? Our load. Now, before we consider panel C, we are going to use the same approach we use for our what? Internal work done. So we are going to divide panel C into what? Segments. Alright? Okay, dividing it into segments. So we call this segment C1, call this segment C2, and call this segment C3. So let's start from segment C1. Okay, so for our C1, so we are considering this rectangular segment, all right? Our external work done is equal to what? Our given load 18 times area. Area of a rectangle is simply what? Length times breadth. What is our length? Our length is what? 10 minus x. So we have this point to this point to be 10 minus 2x. Okay? This is x and this is x. So this is 10 minus 2x, which is our what? Length, and our breadth is what? 2.5 meters times 2.5 meters. We have gotten our load multiplied by our area. Next is to consider our what? Deflection of the center of gravity. And for a rectangle, it's giving us what? 1/2. Okay? So for a rectangle, it's always 1/2. And for a triangle, it's always 1/3. Okay. So let's carry out this computation in a simplified manner. So 18 times 2.5 times 1/2 will give us what? 18 times 2.5, okay, times 1/2 will give us what? 22.5 multiplied by what? 10 minus 2x, okay? So 22.5 times 10 is equal to what? 225 minus 22.5 times 2 will give us what? 45. Adding the x, we have x. All right. So this is our external work done at this rectangular segment. Now we need the total external work done for this entire segment. So we determine for this, multiplying the value by 2 and adding to this, we have the external work done for the whole segment. So for C2, which is a triangular portion, a triangular segment, external work done is simply equal to what? The load, which is what? 18 times, this is the segment we are considering, okay? This is our base, this is our height. Area is what? Of a triangle is half base times height. Half of the base, x, times height, which is from this point to this point, which is half of this span, and that's what? 2.5 times 2.5 times the deflection of the center of gravity, which for a triangle is giving us 1/3. Alright, so we have this to be equal to 18 times 1/2 times 2.5 times 1/3 times x. So we have this to be what? We have this to be equal to 7.5x. This is the external work done for what? This segment. Now let's get the external work done for panel C. Okay? So total external work done So the total external work done for this whole segment we are considering, which we are calling what? Panel C, is simply what? The external work done here, plus the external work done here, plus the external work done here. Now we know that these two segments, not minding my drawing, they are not to scale. We know that the external work done at these two segments is what? The same. Hence we add both of them, which is simply do what? It's simply 2 times 7.5x. So this is equal to 2 times 7.5x, which is the same thing as 7.5x plus 7.5x plus what? The external work done on this C1, which is equal to what? 225 minus 45x plus 225 minus 45x. 2 times 7.5 will give us what? Okay, so we have 2, this is equal to 225 minus 45x minus what? 2 times 7.5 will give us what? Plus 15x. So this is equal to 225 minus 45x plus 15x will give us minus 30x. Hence, this is the external work done for what? This segment. So I haven't gotten the external work done for this segment and the external work done for this segment. We know that this segment and this segment are what? Equal. This segment and this segment are what? Equal. Hence, the total external work done will be the external work done for segment A, B, C, and D. Summation of external work done, okay, is equal to what? Work done is equal to external work done at what? A plus B plus C plus D. Alright. And that is equal to, what is our external work done at A? Our external work done at A as calculated earlier is what? 15x. Knowing that it is the same with segment B, plus for B, 15x. Plus external work done at C is what? Okay, so this is C and D are the same, so it is plus 225 minus 30x plus 225 minus 30x. So I'll put that into B plus 2 times 225 minus 30x. Alright, so 15x plus 15x will give us 30x plus 2 times 225 will give us 450 minus 2 times 30 will give us 60x. Okay, so we have this to be equal to 450 plus 30x minus 60x. So plus 30x minus 60x will give us minus 30x. So we have this to be equal to 450 what minus 30x. So we have been able to get the summation of our external work done, and we had gotten the summation of our what internal work done earlier. So our next step will be to equate our external work done to our what internal work done. Okay, so using the concept of the principle of virtual work, so summation of external work done, okay, is what equal to what summation of internal work done. What is our external work done? 450 minus what 30x is equal to what is it? What was the summation of our internal work done? It was m into 10 plus 8x all over x. Okay. Now at this point, let's simply make x subject of the formula. So we simply divide both sides by what? This expression. So we have m to be equal to what? 450 minus 30x all over what? 10 plus 8x all over x. Now, at this point, x goes to what? The top. In a simplified format, we have this, okay, divided by 10 plus 8x all over what? X. So, to carry out this computation correctly, we simply what? Multiply. And then this is what? Inverted. So we have what? X all over what? 10 plus 8x. So we are going to have what? Our m to be equal to what? X multiplied by this 450x, right? Minus 30x squared all over what? 10 plus 8x. Now, if we know the value of our x at this point, we are asked to determine our what? Moment. Now, at what point do we get our maximum moment? We get our maximum moment when the differentiation of our moment with respect to x is what? 0. Okay? So at the point where we differentiate our moment with respect to x to be 0 and is 0, we get our what? Maximum moment. Hence, our next task will be to differentiate this moment with respect to what? X. Now, to differentiate this, we can see that we have what? A numerator and a denominator. Hence, what method do we use? Quotient rule. Okay, now, just as a reminder, for quotient rule, if we have y to be a function of x, okay, the y dx using quotient rule is equal to what? Is expressed as v du dx minus u dv dx all over v squared, where v is the what? Denominator, u is the what? Numerator. So this is simply saying, to differentiate this, write the denominator first, then differentiate the numerator, okay, minus, write the numerator first, differentiate the denominator, and then divide through by what? The denominator squared. So let's do that. Hence, the m all over the x is equal to what? What is our v? Our v is what? 10 plus 8x. This is equal to 10 plus 8x, which is our v. The u, the x, differentiate the numerator. So let's differentiate. If we differentiate 450x, we are going to have what? 450. Alright? Minus, if we differentiate 30x squared, it's going to be 2 multiplied by 30. Remove 1 from the power. So 2 times 30 is 60. X, remove 1 from the power, it will be 60x. 60x. Alright? Okay? Minus, what is our u? Our numerator. Our numerator is what? This expression. So this is minus, okay? 450, alright? X minus what? 30x squared. Alright? Okay, so we have our what? U. Okay? Next is to what? Is the v over the x. What's the v over the x? Differentiate what? The denominator. If we differentiate this, what do we have? 8. There is no x here, so we are only differentiating what? This portion. So we have multiplied by what? 8. Okay? All divided by what? V squared. What is our v? Our denominator. It is 10 plus what? 8x, all what? Squared. And remember this differentiation, at this point, differentiating the moment with respect to x will give us what? For maximum moment, it will be equal to what? 0. Okay? Okay. So after differentiating, okay, v, which is our denominator, and then we have this to be equal to 0. So at this stage, what do? We simply cross multiply. Okay? So we have this multiplied by 0 and this multiplied by 1. Obviously it's 1. So we have what? Okay? So we have 10 plus 8x into 450, okay, minus 60x, alright, minus 450 x minus 30 x squared multiplied by what? 8 is equal to what? 0. Remember, we did what? Cross multiply. So if you cross multiply, this is multiplying 0, hence it is equal to what? 0. So it's just like we have, let me call all this expression v. So we have v over, let me call this k over k is equal to what? 0. If we cross multiply, what do we have? We have k times 0. K times 0 is equal to what? V. Hence, this side becomes what? 0. That's just what happened there. So at this point, we go ahead to simplify. So let's take it step by step. Okay? So let's expand the brackets. Alright. So 10 times 450 will give us what? 4,500. Right? 10 times minus 60 will give us minus 60x will give us minus 600x. 8x times 450 will give us what? Plus 3,600x. Alright? 8x times minus 60x will give us what? Minus 480. Minus 480x squared. Let me bring this other part downward. Minus 8 times 450x will give us what? 450x times 8.
3,600.
3,600x. Alright? 8 times 30 will give us what? Now, this is minus, so it's going to be minus 240x squared is equal to 0. Okay, so at this point, we have this expression, right, coming from the expansion of this. So at this point, we have minus this bracket 450 x times 8 give us 3600x, and minus 30 times 8 minus 240 x squared. So let's open up the bracket. So at this point, we have 4500 minus 600x minus 600x plus 3600x will give us what? 3
plus 3000.
Okay. So this will give us plus 3000 x minus 480 x squared. Opening up this bracket, minus 3600 x plus 240 x squared. Alright, so at this point, let's take like terms. Okay, so let's take for x squared first. So we have minus 480 x squared minus 480 plus 240 x squared plus, let's take the like terms for x in bracket 3000. Okay, 3000 minus
3600.
What's going on here?
3000
minus 600 plus 3600
3000
is plus 3000.
Oh, you got.
So we have this to be 3000x minus 600. Okay. X plus the constant 4500. So minus 480 plus 240 will give us what? Minus 240.
minus 240
Minus 240 x squared
minus 600x
minus 600 x
plus
4500 is equal to 0. Note this expression is equal to 0. Okay? So at this point, we can simply multiply through by minus 1. Okay? So if you multiply through by minus 1, we have this to be 2400 x squared plus 600 x squared. X plus 240, this is 240 x squared plus 600 x minus 4500 is equal to 0. So to reduce the coefficient of x squared, we simply divide it by what? 240. So we divide it by 240. Okay? Divide it by 240. Divide it by 240. Okay, so we have x squared
plus 2.5x
plus 2.5x
minus 18.75
minus 18.75 is equal to 0. So at this point, you can see that our quadratic equation is clearly informed. So we use the formula method to find the value of x. So we know that x is equal to what? Minus b plus minus square root of b squared minus 4 all over what? A. Here our a is coefficient of x squared, our b is coefficient of x, and our c is our constant. So we have our x to be equal to minus 2.5 plus minus square root of 2.5 squared minus 4 times 1 times minus
18.75
times minus 18.75 all over 2 times 1. So we have our x to be equal to 2.5 plus minus. Okay. Square root 2.5 square root equals what?
5.
5 minus 4 times 1 times minus 18.5 is 40.
Not 5.
2.5 square
It's 6.25.
2.5 square gives us 6.25 plus, because this is minus and this is minus. So 4 times 1 times 18.75. 4 times 1 times 18.75. 75. All over 2. Okay. So we have our x to be equal to x equal to 2.5 plus. What is the square root of 6.25 plus 75?
8.
I have to do it minus 2.5.
What is that?
Minus 2.5.
This one. I beg I'm going to watch calculator now.
9.01.
Yes, okay. So we have square root of 6.25 plus 75. This is plus minus to be what? 9.01. To be 9.01 all over what? Hence, now at this point, we will be taking the positive value of our x. Okay? So we'll try first. So x is equal to minus. So try first. X is equal to minus 2.5 plus 9.01 over 2. Okay? So x is equal to, so let's try minus 2.5 plus 9.01 all over 2.
That 3.26.
3.26 or minus 2.5 minus 9.01 all over 2.
Minus 5.8. 76.
Minus 5.76. Okay, so at this point we'll be taking the positive value as our s. So to determine our moment, we'll simply substitute the value of s, which is 3.02, into our moment equation.
You don't come early, you must pay the class.
So we have n to be equal to 450x minus 30x squared all over 10 plus 8x. So at this point, substituting the value of our x, so we have our moment is equal to 450 into 3.26, okay, minus 30 into 3.26 squared all over 10 plus 8 times 3.2. Hence the value for our moment is what? 31.8 kilonewton meter. So for the given problem, this is how we determine our moment for our slab within the yield line analysis.